Good evening, everyone. My name is Inderbir Singh Riar. I'm an associate professor here in the Azrieli School of Architecture and Urbanism at Carleton University, and I'm delighted to welcome you to the promise of a very exciting and engaging evening. This year's an open forum series is made possible by the founding sponsors' commitment to situate architecture and the allied arts as matters of public concern. Speakers are arriving from Sydney, Seoul, Santiago de Chile, and many more points near and far. The leading Montreal practice, Pelletier de Fontenay, comes next Monday night to Ottawa Art Gallery, and the innovative and experimental Bureau for Architecture, Research, and Environment from South Korea speaks on November 27th at Dominion Chalmers Center. The calendar continues in January with voices such as the Observer and Guardian newspaper critic Rowan Moore and the United Nations Special Rapporteur on the Right to Adequate Housing, Balakrishnan Rajagopal. We very much hope to see you at each lecture. Tonight's event, like all others, occurs on traditional and unceded territory of the Algonquin Nation. Such acknowledgement reminds us time and again to consider meanings behind phenomena of land, territory, and ground. This evening's lecture title, Frozen Ground Truths, accordingly invites reflection on what environment and its measure reveal. How does a frozen ground convey coded messages or submerged signals or indeed hidden truths? The ground, of course, isn't inert and it isn't frozen. It's teeming with life, even if the human world, namely the political world, deliberately makes myths, namely political myths, of immutable, thus endlessly abundant and fruitful landscapes. When we see an image of tonight's speaker, Susan Schuppli, lowering a microphone into a crevice, we might wonder if resulting field recordings allow the earth to speak directly to us. Snow and ice in an age of human-made climate change are talking suddenly, emitting ever sharper frequencies. Deep time communicates now in notes and pulses of alarmingly shorter duration. Glacial melt, we fear, shouldn't have a soundtrack. To capture and to amplify such noise, nevertheless offers among the most profound reckonings with the awesomeness of nature and our capacity to destroy it. This is but one powerful dimension of Susan Schuppli's remarkable work. Susan Schuppli is professor and director of the Center for Research Architecture at Goldsmiths University of London, where she also serves as board chair of the group Forensic Architecture. She received her PhD at Goldsmiths and participated in the renowned Whitney Independent Study Program after taking her MFA at the University of California, San Diego, and her BA at Simon Fraser University. Professor Schuppli's earlier work examined media artifacts from photographs to audio transmissions emerging in sites of contemporary conflict and state violence. Her current projects extend similar notions on producing an extreme archive, as she puts it, of environmental disasters and climate change. Investigations span legal analysis and public advocacy, as well as theoretical reflection and creative exploration, in order to understand how transformations wrought by global warming are generating new forms of evidence. Granting agency to the non-human as witness, whether the technological realm or above all the natural world, drives Susan Schuppli's attempts at expanding the fields of action and justice. The premise is sobering for us Canadians who belong to the land of snow. We face an election next year likely predicated on a pernicious twist to establishing a non-human actor, namely the rhetorical construction of axe the tax, readied as evidence for climate denialism, illiberalism, and rank populism. With this worry in mind, and with anticipation of the rich and rigorous forms of action we shall encounter tonight, please join me in welcoming Susan Schuppli to the podium.
Great. Thank you so much, Inderbir, for the invitation, and it's already been a real treat to meet, to tour the facilities and to meet some of you. And So I really hope that once the presentation sort of unfolds and concludes, that we can then open up into a kind of broad-ranging discussion. I'm going to just move ahead, in fact. I just thought by way of introduction, and you might have actually sort of signaled that, in some way, the project that, or the projects rather, that I'm going to talk about tonight, and I have a series of notes and then clips from my documentary practice, but also some writing that I've generated in relationship to a book chapter that I'm writing around thinking about the relationship of the field to the production of truth. But this work, in many ways, begins actually, and I see there's actually a typo there, it begins in the Geological Survey of Canada because in the 60s and into the 70s, the Canadian collection of Arctic ice cores was actually housed in this facility. And then in 2011, the government, the Harper government at the time, there was a reallocation of its funding in terms of supporting the research of glaciology and in Canada. And so the Ice Core Archive, which houses the most unique collection of cores from the Canadian High Arctic, was literally on the verge of having the sort of plug pulled out and the entire collection kind of melted. So these are just a couple of images of this really important collection of earth evidence, as I tend to call it, that then became part of a multi-year inquiry under this sort of research framework of listening and learning to ice. But tonight's presentation, as I said, really focuses on the practice of ground truthing. So let me begin. Can everybody hear me properly? Okay. In an interview I conducted with geologist Edward Brooke when working on a documentary film about ice cores, he emphasized that everyone working in his geochemistry laboratory must make their way to the field at some point to gain a broader perspective on their research. How, he asked, do they, as laboratory scientists, understand the relationship between the ancient ice stored in their freezer facility and the natural ice sheets of Antarctica from which their core samples were once extracted over 15,000 kilometers away? What kinds of practices and protocols do coring operations need to establish such that the scientific assertions that will be made on behalf of ice maintain their evidential robustness, especially when scientific findings move into policy forums where they may eventually be translated into political demands? How does the quantitative data that they produce through their chemical analysis, which is aggregated into global climate models, retain any sense of the local context and conditions from which the ice was sourced? Let's hear from Ed now.
We really are laboratory focused. We spend most of our time on the lab end. But collecting samples, I think for an earth scientist, being in the field to collect the samples you're working on is really critical. And also for a lot of us, being able to do that is one of the reasons we like our work. Although we don't spend that much time in the field relative to the time in the lab, it's really important to understand the context that you've collected the sample in. Even if it's a deep ice core that's been drilled for 5 years and 50 people worked on it, it's really important for people to go there and understand how the material came into our hands and how we kept track of the depth and how certain we were about where it came from and all kinds of things like that. So everybody that works here gets to spend some time in the field, even if they don't really need to, just to make sure they have the whole picture.
And I thought I would also play a little bit of the actual documentary so you start to get a sense of the really important role that sound is going to play in a lot of my projects. And I often work with musicians and composers in addition to the work that I do myself through various sort of field recording practices to somehow transmit the internal life of ice through various acoustic registers. So I'll just play a bit from the end. So the images there are a very, excuse me, that's actually a very small ice coring operation. Ed talked about the operations in Antarctica, where there's a team of hundreds of people working over 5 years. Extracting one ice core costs about 20 million US dollars from Antarctica. So it's in a very expensive operation. So the fact that the Canadian government was going to literally unplug the freezer facilities in Ottawa. Luckily, Martin Sharp, a glaciologist at the University of Alberta, came up with a plan to save the collection. Yes, an ice core could be re-drilled again, but it's logistically complex and expensive. So although they're not technically unique objects, as artifacts that have been drilled from decades in the past, in some way, they are fairly kind of singular nonetheless. So ice cores are slender vertical columns of compacted snow that scientists extract from the planet's frozen reserves as they tunnel deep back in time towards bedrock. These meter-long sections of ice, pulled primarily from the ice sheets of Antarctica, Greenland, and the Arctic, although subalpine and even endangered glaciers have been data mined in recent years, carry vast amounts of environmental information about the Earth's climate systems. Notably, they provide us with direct access to the temperature records and chemical composition of our early atmosphere, because trace evidence in the form of tiny bubbles of air sampled almost 1 million years ago are trapped inside their compressed layers. Annual accumulations of snowfall that have transformed the planet's ice sheets into the high-resolution data set for climate reconstructions and modeling. In shallow or more recent cores, distinctive sedimentations can even be seen with the naked eye. When these frozen field records are unsealed under laboratory conditions, they enable scientists to study the planet's pre-industrial environmental histories and compare them with more contemporary readings, which is why, in part, ice cores are repeatedly referred to as forms of technical storage media and as technologies for accessing the big data of past climates. And here I thought I would take you into the 2 clips from the documentary Ice Cores. So the first clip is just the beginning of the film, where I'm really trying to look at the transformation from an ice core sample into a data set. And then the second clip takes us into the Canadian Ice Core Archive that, as I said, is now at the University of Alberta. And I'm pulling these clips from different bits and pieces in the films, so we'll now just sort of enter into the ice core archive, and there's a bit of a description. You get a sense of what these kind of environments look like.
The Canadian Ice Core Archive, now at the University of Alberta, shelters this unique collection of historic ice. Cores from Mount Logan in the Yukon, as well as from the Arctic archipelago, including the Penny Ice Cap on Baffin Island, the Prince of Wales ice field and Agassiz Ice Cap both on Ellesmere Island, and the Devon Ice Cap on Devon Island are all preserved within these cylindrical tubes.
So not only are ice cores key to detecting concentrations of greenhouse gas emissions over time, they are also crucial for correlating environmental data obtained in other parts of the cryosphere and via other modes of acquisition. From the findings of glaciologists who set out to measure the annual mass balance changes of Himalayan mountain glaciers using bamboo stakes along the ablation zone, to the geospatial data captured by the fleet of dedicated ice satellites tasked with monitoring sea ice thickness and changes in the dynamics of polar ice sheets. This is because ice cores contain both a hyper-local record of environmental conditions at the field site, as well as a radically delocalized planetary archive of Earth evidence transported from afar. The practice of correlating data points assembled from such diverse inputs becomes a form of verification across time scales and spatial scales in which the field comes to play a constitutive role in the production of truth. Any material that is released into the atmosphere or enters the gas phase will eventually be carried by weather and wind systems to settle on the planet's ice sheets. Weather eruptions such as Krakatoa in 1883, which spewed vast amounts of volcanic ash into the air, transhemispheric dust storms that originated in the Sahel, or anthropogenic pollutants and airborne emissions in the form of greenhouse gases, industrial aerosols, particulate matter, and nuclear fallout. All is archived in ice. While also filming in the Canadian Ice Core Lab, as it's now called, at the University of Alberta, I asked glaciologist Martin Sharp if he considered ice cores to be a kind of material witness, a concept that I developed in my book project some years ago to account for the emergence of a forensic imagination in which non-human entities would come to play a decisive evidential role as witnesses to historic events. This is what Martin had to say.
Ice cores, by their very nature, are a diminishing resource. They are used up as they are worked on, and the ice caps and ice sheets from which they were retrieved are now also undergoing dramatic change.
I think you can say that ice cores are essentially material witnesses of what we humans as a species have been doing to the atmosphere of our planet over a period which goes back at least thousands of years and maybe even longer than that. Anything that produces particulate material or material that goes into the gas phase that can be transported around and then removed from the atmosphere, particularly if it's removed under cold climate conditions, has the potential to be recorded in glaciers and ice sheets and to produce records of the history of use of those substances. And of course the same is true for natural substances too, so you can get records of dust storm activity, examples of dust fallout really near the top of Mount Logan in the Yukon, for instance, where the source of the dust was traced to the Gobi Desert in China. There's a lot of different facets of things that go on in the environment, both natural and anthropogenic, that ice cores are effective at detecting and documenting.
Ice cores thus perform an important function in establishing tie points between disparate occurrences and localities, a forensics of frozen matter capable of reconnecting the traces that planetary processes have pulled apart, to the extent that they've even been compared to the investigative potential of genetic evidence. It's almost like DNA sequencing, said glaciologist Alison Cristicello, who's now the director of the Canadian Ice Core Lab at the U of A. There's an online library, she says, of the chemical makeup of the particles from the biggest volcanic eruptions of the past, big enough that they sent ash all around the planet. You can analyze the particles in your core sample and match them to the right volcanic eruption, and thus the correct date. This provides a tie point of an exact known age to use as a reference point for the layers in the ice core record. And while paleoclimatologists consider ice cores to be classic data proxies because they contain climate markers such as oxygen isotopes, methane concentrations, dust content, and other parameters that extend our insights far beyond the records of instrument-based measurements, I've always argued that this designation is too narrow. In archiving the actual material remains and atmospheric chemistry of early Earth, ice cores offer up evidence that can be measured and analyzed directly. For me, this makes them more than proxies. It makes them material witnesses and evidential agents. Whereas other data proxies, such as tree rings and ocean corals, express changing climatic conditions indirectly through morphological variations that scientists can study and interpret in order to extrapolate quantitative data about precipitation, temperature, and solar activity. Ice cores thus play a vital role in the relay between disclosing evidence of external events and the operations of ground truthing, a term that is used to describe methods for calibrating remotely acquired or inferred data to local realities in the field. Within the sedimentary strata of Arctic ice, we find evidence of the amplification that drives the decline of sea ice cover in Svalbard and the thinning of Greenland's ice sheets, evidence also revealed by Earth observation satellites that monitor the cryosphere. In the tiny bubbles of ancient air compressed within Antarctic ice, we find geochemistry validating the fieldwork of Earth scientists laboring thousands of kilometers away who are measuring the retreat of glaciers and the thawing of permafrost caused by atmospheric warming. In the accretion of pollutants and microplastics trapped in polar ice, we find further confirmation of the damaged ecosystems and changing life worlds that indigenous communities have long been recounting. In the temporal sequencing of yearly layers of snowfall, we find the mathematical proofs that run long-term climate simulations in computer labs just up the road from where I live in London in the UK. These are all critical material proximities that are made manifest by the relational capacities of ice to forge evidential connections across time and space. I thought I would just quickly play a short clip from a documentary that I produced that was shot in Svalbard that's called Climate Signals from Svalbard, just to give you a sense of the sort of different strategies that I've been developing and the different sort of contexts in which I've been working. So I'll just play a little bit. This is a satellite ground station. The extractivist histories of Svalbard began in its subterranean seams of coal, as laborers worked to mine dark matter within its cramped and claustrophobic tunnels. Today it's data that is mined, as the archipelago's glaciated landscapes become increasingly populated with the networked infrastructures of digital transmission. A polar pulse that flows from within the veins of silica. On the main volcanic island of Spitsbergen, research stations track atmospheric, oceanic, and terrestrial changes alongside Svalsat, the world's largest and most northerly satellite ground station. Coal mining was established with the outbreak of the First World War, when 2,000 workers were sent from Sweden to set up the Svea mine. Even then, signs of climate breakdown were already expressing themselves as permafrost thaw collapsed the mine's underground tunneling and sea ice tore through loading docks in the harbor. back one. Yeah. When ground truthing media acquired via remote sensing platforms, the spectral image features of the surface of the Earth must be compared to actual physical features that can be observed and measured in the field. These ground truths are gathered through a combination of site-based work, maps, local knowledges, and personal experiences. The field thus becomes the paradigmatic training site for determining the parameters or decision rules that will guide the software in classifying similar spectral characteristics in other regions that the satellite also passes over. Through this methodology, key indicators of particular types of land-based conditions are identified and aggregated to produce a training set. However, in landscapes comprised entirely of frozen water, the process of ground truthing becomes even more complicated because of the material flux and optical confusion that ice poses to satellite systems, which in turn hampers image interpretation and analysis, a problem that is not easily overcome through fieldwork because temperature extremes and ice hazards can further limit who has direct access to the field. Yet embodied and situated experiences of cryospheric environments are often pitted against the more abstract realms of climate science, especially those associated with remote sensing, laboratory analysis, and computational modeling. What anthropologist Karine Gagné refers to as a technocratic imagination, which she argues tends to denigrate glacial knowledge that emerges out of the field and through local encounters with affected communities. Glaciers, she writes, are known through different epistemic practices, and the detached and dispassionate scientific outlook on glaciers, which entails a rationalization that allows their conversion into spatial and geographic data, is only one way of knowing glaciers. What if we could see knowledge about glaciers as something that is not anchored in a technocratic imagination? What if glaciers were not considered merely as segregated ice summits, but rather as embedded in a living mountain environment home to humans and other beings? While scientific accounts of glaciers is largely subsumed by an episteme of objectivity that parses glacial events into quantified units of data so that they can be integrated into mathematical climate models, it's still clear that the scientists who actually work in the field do develop intimacies with ice that are relational and sensate, embedded in daily habits and practices. As my collaborator Farokh Azam put it, glaciologists are those who sleep on ice, meaning those who have situated perspectives and intimate experiences of the field, where labor is often physically grueling and bodies are directly entangled with the cold thermal mass and material instabilities of ice. While working in the Canadian High Arctic, Martin Sharp once made an audio recording documenting the accelerated melt of the Belcher Glacier in the Devon ice cap, which he submitted as anecdotal evidence to the Intergovernmental Panel on Climate Change more than a decade ago. He wanted the policymakers to sense the immediacy of the dramatic changes that were taking place in the actual context in which their graphs and statistics had stakes. I included Martin's recording on my LP Ice Records released by Beck, and New York Times music critic Grayson Haver reached out to Sharp for the story. This is Grayson Curran writing. 7 large microphones and GPS sensors monitored the rate of the melting ice atop the cap, while several seismic monitors sensed how the ice moved along the Earth too. Almost as an afterthought, Sharp set up a little Sony handheld recording, hoping it might capture the essence of the frigid stillness where he often worked. The result teemed with surprises. A snow bunting perched on the rig and sang. Gulls circled above, and below, as deep ice gradually thawed, an unexpected symphony unspooled. Water trickled past the microphone, creating a vertiginous drone, while tiny bubbles, air trapped inside the ice, perhaps for centuries, exploded incessantly. As Martin put it, it gave people a different way into what he was talking about other than just sewing slides. The sound conveyed what it was like to be there. Sharp's field recording of the Belcher Glacier momentarily intervened into a transnational climate policy forum that was dominated by spreadsheets and graphs, one that by necessity must limit the sensorial complexity of the field to calculable data points if it is to arrive at a 1.5 centigrade threshold agreement for average global temperature rise. When scientists feed the data they have acquired, whether from fieldwork, laboratory analysis, or via remote sensing platforms into predictive models, local communities and local particularities tend to disappear, since the scale of the climate futures that they're modeling is global. Sharp's playback of his field recording during IPCC proceedings was in essence an attempt to overcome the distancing that such scalar operations tend to reify. Monitoring the acoustic dynamics of ice sheets and glaciers, whether by technoscientific means using specialized microphones or via acts of listening using our human ears, has become an important methodological approach for me because of sound's ability to invoke intimacies with the material conditions of climate change. Sound, like temperature or smell, brings one directly into the contact zone of the event because of its somatic capacity to effectuate the body directly. Sensation, writes philosopher Brian Masumi, occurs when the outside comes in as, quote, a continuously variable impulse or momentum that can cross from one qualitatively different medium into another, like melting ice into sound waves or the flash of light off the surface of snow into momentary blindness. In these encounters with environmental media, the field enters the body to become a felt effect, a kind of elemental transduction between different corporeal mediums. Knowledge of ice must thus be situated and relational. Experiences from the field actively shape scientific insights and provide important contextual understandings of how the work was carried out and the ways in which measurements may have been arrived at and substantiated. While ground truthing has come to play a crucial role in the verification of much remote sensing data, I believe there is room to radicalize this notion from merely a method for assessing the real-world accuracy of machine-based inferences. As my colleague Eyal Weizman has put it, verification relates to truth, not as a noun or as an essence, but as a practice, one that is contingent, collected, and polyperspectival. Ice cores, like all Earth evidence, are part of a broader ecology which includes not just the field sites from which the samples of ice are extracted, the laborers who toil to access them, the technologies and infrastructures needed to manage them, the scientists who study them, and the policy makers that might act on their findings, but also the local communities through which all of this complexity passes in one way or another. This is certainly the situation in the circumpolar north, in the Andes, and in what is commonly referred to as the third pole. It's different in Antarctica because the human community that lives there is a kind of transient one. While the geographically remote field sites of much cryospheric research might suggest that locals are not always living in direct proximity to the fieldwork of glaciologists, the collective knowledge of communities whose existence and indeed survival is dependent upon the water resources of glaciers or the material integrity of sea ice means that local and indigenous knowledge of ice is expansive and considerable. Yet to date, no ice core studies have incorporated indigenous knowledge in their interpretation of ice core data. As Professor of Environmental Studies and Geography, Mark Carey notes in his introductory remarks to In the Shadow of Melting Glaciers, which examines the ways in which Andean communities have had to adapt to glacier floodburst events, surprisingly, most research on melting glaciers and research on global warming and climate change more broadly focuses primarily on scientific processes and the physical environment rather than people. Researchers, he argues, study ice cores and other forms of proxy evidence to understand long-term climate change, producing data sets and projective models, whereas people and the local knowledge held by communities rarely appears in any of these scientific counts. Moreover, if the ground is the epistemic site that structures the production of truth in much cryospheric research, what of the fact that the very frozen ground itself is often stolen or colonized land? How could any ground truths be established that don't acknowledge this fundamental condition in their drive to verify? Can the practices that shape the study of glaciers and ice sheets, for example, be expanded further still to include the truths inscribed in the ground itself as the precondition for any technoscientific work to unfold? That is to say, a ground truthing practice that also makes explicit the fact of being on the land and the taking from the land, rather than simply neutralizing this relationship or consigning it to a tick box exercise in the form of a research ethics review. This is not to merely advocate for ground truthing as a mode of syncing up remote and proxy measurements with indigenous knowledge so that data sets become more robust, nor to simply translate the relevance of scientific findings into local advocacy campaigns and environmental policy decisions, but to produce an ecology of practices around cryospheric research. To date, neither the very land from which the ice is sourced, nor the communities whose life worlds are wholly reliant upon ice has been adequately factored into the scientific practices dedicated to the cryosphere. Given the practical necessity of ground truthing, combined with the relatively limited time span of data sourced from dedicated ice sensing satellites, intergenerational knowledge of ice would have much to contribute to such verification practices. However, because the frozen landscapes of our planet intersect with many different political realities, from the treaty-based geographies of Antarctica and the Svalbard archipelago, the nations of the circumpolar north, all of whom are home to indigenous peoples that live in regions with varying degrees of self-governance, the mountain ranges of Asia, where climate refugees from ancestral villages are on the move due to glacial retreat, to the Andes of South America and the Alps of Europe, practices and protocols around the study and procurement of ice varies considerably. In the Canadian North, permission must be sought and received prior to working on Indigenous land, but this is not the case in many other contexts. For all those who live and work on or with ice, the relationship is often one of intimacy, organized by practices of care. Knowing how to traverse a landscape by paying close attention to places where snowdrifts might conceal treacherous crevices, or learning how to handle an ice core by gently brushing its curved surfaces free of sublimated frost. The changing material states of ice make demands on us to modify our behavior and interactions with it. This also holds true at the supranational scale, even if climate change adaptation is far from what is politically required. Glaciers and ice sheets have a vital presence, which is why we must also engage with them as a kind of living witness that offers continuous testimony about the context in which they persist and the many practices and life worlds they sustain. Again, I'm reminded of Gagné's point that ice isn't a geospatial entity or cartographic adversary to be conquered like the climbing of a Himalayan mountain peak or the failed voyage to navigate the Northwest Passage, which is largely how the colonial imaginary sought to interact with ice. Nor is sea ice simply frozen ground that can be fractured at will by the US or Canadian Coast Guard in order to secure maritime trade and maintain Arctic sovereignty. Ice is relational and communal, part of complex living ecologies that are home to humans and other beings. Sounding glaciers by tapping them with an ice axe or wooden stick to reveal the sonorous cavities of hidden crevices was a common practice for navigating the mountainous terrain of Ladakh in the 19th century, whereas reliance upon the abstractions of European survey maps would often prove fatal. Intimacy with ice was thus essential for survival. And here I just wanted to signal something that is was an implicit but largely unrealized aim of our listening to ice research in India, was to explore the ways in which we might start to think about decolonizing the imperial legacies of what is referred to as pink ice. So pink ice being all of the cryospheric locations that are part of the Commonwealth. So Commonwealth maps were often the countries of the Commonwealth and the colonies were tinted in this sort of rosy pinky hue. So this term pink ice emerged at a certain sort of point. So how might we think about the imperial legacies of pink ice that have set up expeditionary imaginaries upon which the foundations of glaciology in former British colonies such as India have been laid, both the formation of its research institutions and the mobilization of forms of expertise that draw upon Western scientific methods to the exclusion of local experiences, native languages, and indigenous wisdom. And just as an aside, this is another phenomena. We're talking, once again, something that comes out of anthropogenic induced sort of climate change, but this is the phenomena of algae that is, in fact, transforming ice sheets into this sort of strangely bizarre hued pink kind of landscape. So the cold-thriving algae contains synthetic chlorophyll, which is green, but also has a secondary red pigment, which protects the algae from ultraviolet light and absorbs energy to melt snow and provide the algae with liquid water. I wanted to wrap up by focusing on the listening to ice research, which continues, and then I'll play a clip from that at the end. So in addition to our technical work at Drang Drung Glacier in Ladakh, setting up a weather station or deploying a long-term acoustic recorder to document the calving and melt rate of underwater ice, which we see here, we also focused on listening practices as a way of multiplying the sources of information wherein environmental knowledge resides. And there's FISA conducting some field recordings. Through our interactions with local villagers, we heard stories about bears moving down the mountains earlier each spring, and that the glacial runoff, which feeds the stream paths and supplies their water, was diminishing. We met an elderly song collector, Murup Namgayal. We met an elderly song collector whose personal archive of poems and folk songs recalls the mountainous landscapes of Ladakh in the 1960s. When Ashkau villagers placed their ears to the ice at Drang Drung Glacier during one of our workshops and listened to the acoustic reverberations in the Moline, they described what they're hearing as the noise of boiling tea and the whirring of a helicopter overhead, the sounds of ice reconnecting them to familiar everyday contexts, affirming the infinite number of ways in which glaciers are part of their extended life worlds. I'll just play another short clip. This time we're not listening to the Moline where we've inserted various hydrophones into the crevices.
Yeah. It's good. Yeah, it's good. Azura, zera. Mera. Nasıl soda? Kamu nasıl soda mera? Nasıl yiyin?
While working with the grassroots organization Local Futures in Leh, we met Nishant Tiku, an environmentalist based at the Himalayan Institute of Alternatives in Ladakh, who's coordinating the Ice Stupa project to grow artificial glaciers in Kulum, the Himalayas' first village to have experienced acute climate migration. Oops. Sorry. Should be this one here, I think.
If you see the recent IPCC report, it says about 85 or 87% of the world glaciers are receding at such a pace that they'll disappear by the end of the century. So these kinds of facts are scary, yes, but these are also true. So as a community, we try to, find solutions basically for howsoever long we can. We are doing these solutions in a particular anticipation that by the time the conditions are worse, our solutions would have improvised to a level to address that worse conditions. So that is the idea basically. So the story of Kulum goes like in the last few decades how due to global warming, climate change, reducing precipitation, acceleration and melting of glaciers, the water flowing through the valley has reduced every year, year after year. Back in 2006-2007 they were stuck with a very bad drought. They couldn't get any water and that was the first time ever they had to leave the entire 8 acres of upper village fields empty. They didn't do anything on that. Moreover, on top of it, in 2010 there was a big flash flood. Now a valley like Kulum that doesn't have a feeding glacier right on top but gets fed by glaciers around it is heavily dependent on spring water sources, which is all through up in the upper valley. Now these spring water sources in 2010 floods, they got inundated. There was no other way for water to come out. The olden sources and the olden Uras are water channels, Uras and zinc networks which was working in this village for hundreds of years, they got destroyed. And people lost hope. One after the other, families left the entire village and what you had was an entire abandoned village, perfect homes, perfect fields, but nobody stayed there. So Ice Stupa is trying to bridge the gap on reduced precipitation, receding glaciers, and due to these factors, we don't have enough water in early spring when the sowing season is there. Now the agricultural season is only so long. It's only long for like 4.5, 5 months. If you don't have the crucial first month water, the first few supplies of water, then you cannot farm, you cannot do cultivation at all. So that is what the bridge gap this ice stupa or any artificial glacier aims to fill. This is the gap we aim to fill, to provide water in months of like April and May, when there is no stream or very less water in the stream. And then when the water comes in the stream, the glacial melt reaches there by June, July, then ice stupa is already melted by then. It has solved its purpose. Yeah. This activity is unfolding of the pipes, the pipe which take the water from the source and develops the artificial glacier down. And this was in the last 2020 winters. So we made 3 ice stupas, as I said before, and about 7 artificial glacier structures in the village. So this was one of the ice stupas with the weather station right next to it, to understand the local climate and the weather of the region. Not the region, this particular valley in itself. And then this weather station was also helpful to understand how an ice stupa melts. What are the factors? So we had a solar radiance in this as well, to understand how much water, if an ice stupa holds about 1 million liter of water, or for example 100 million liter of water, how much of that is evaporated? How much of that seeps and goes underground? How much of that is actually usable? It helps us to plan further and plan better. So these are the different ice stupas that were made in Ulum village this year. So this particular one is very interesting. So if you can see right here, there's a pipeline that you see that is heading up to the sky, right up to this point. So what we did, from the higher altitude, we got a pipeline that comes down and then again climbs up. Water matches its head. It's a spring water source. It is warm as well. And then these valleys are not too wide. These are narrow valleys. So we took iron strings and we tied it across the valley. And then we tied the pipe on top of the string, so that the water is being sprayed from the top rather than coming from the bottom. That saves water as well. And the water is being, coming from the inside. Wind takes a lot of it away. But now the water is directed with force on the structure. So it goes and makes a structure. It's a relatively very easy technique to make ice stupa, relatively a lot safer, relatively a lot cheaper. Whatever we are doing, each and every component has local knowledge embedded in it. Like in first year when we tried to make ice stupa in the village, didn't work. Villagers told us there's spring up in the valley, go there, make there. We were able to save 15 million liters of water. So everything that we are doing is intertwined with indigenous wisdom and knowledge. Because, people coming from outside and bringing technology X, technology Y, technology Z wouldn't work until they understand the local context, until they understand the local knowledge, and it only comes from local people. So yes, every part of our step has that inclusion in it. We had a lot of setbacks. So sound as
So I just wanted to end with a little clip, because I asked Nishant if he had any experiences of sound and ice in the field that were important to him, and this was his response.
sound as in acoustic, physical.
Yeah, like.
Yeah, ice talks a lot. We've seen that in ice stupa. If you stand inside enough ice stupa, during the day, it will have, sun is there, becoming a crack. You can hear it. You can hear when you're walking on ice. During the night, when it's melting, the water is sprinkling up and falling and instantly becoming ice right there. You can hear it. Yes, it's a very interactive. Ice, water, these kind of things, they are more like living. They communicate. It is up to you if you can reply back, basically, or if you can hear and understand. Yeah, that's true.
Great. Oops, that's something else. Sorry, let me get rid of that. So I'm going to close the presentation there, and really hope there's enough materials for you to engage and for us to have a kind of collective conversation. So thanks so much for joining this evening, and I guess we open up now. Is that the plan?
Thank you, Susan.
Okay. Should I bring an image up or something?
Sure.
So we have a background that's...
Susan Schuppli has very generously agreed to take questions, and we have a microphone that we'll pass around, so your voice will be recorded apropos the presentation. So don't hesitate, and I'll bring the mic to you.
I'll just go to my beginning. That's fine. That's a good one.
I've got it there. Yeah, I've got one lady behind you, but
Do you have any examples of indigenous interactions in the Canadian Arctic?
No, I don't, because I haven't worked in the Canadian Arctic myself. I've worked mostly in Svalbard and in India. So I have, it's not the Arctic. I'm running a workshop, an acoustic mapping workshop in with students in and around Dawson in February, but no, that would be an aspiration, but it's not, as of yet, part of what I've managed to do.
Hi, I was just wondering, what do you think that international organizations and groups can further do to protect these ice forms and work alongside Indigenous people?
I mean, it's an urgent question, but also like crazily kind of complex, as I said, because of the very different geopolitical realities that are operating in so many different sort of contexts. Just to give you an example of a project that maybe some of you may or may not have heard about, but UNESCO is running an ice memory project and has for quite some time now, where UNESCO is sending glaciologists to core to drill out samples from endangered glaciers. So they've been to Svalbard, Mount Kilimanjaro, subalpine glaciers in Europe, and those ice samples are stored in Antarctica because basically you have a relatively cost-free freezer facility, an outdoor freezer. So the UNESCO Ice Memory Project, it originated in Grenoble, France. So UNESCO, as an organization, makes determinations as to what it views as part of our cultural commons, our like the heritage, cultural heritage, or heritage that's deemed worthy of preservation and becomes part of a kind of cultural, like common cultural heritage or something, sorry, yeah, common cultural kind of heritage. So here we have a project that in some way has, and UNESCO, because it's a school of architecture, I'm sure you know a lot about the very contested, conflicted histories of organizations of UNESCO and what it means once you have a heritage designation. It has a lot of parameters, and it is very, it's an extremely, it's not, put it this way, it's a very fraught kind of designation to have. It is, I mean, in forensic architecture, we've used it kind of strategically to stop the building of a kind of partition, the Israeli separation barrier, for example, in what was a kind of very ancient Ottoman sort of landscape part of kind of Palestine. But of course, for locals, it has all kinds of like extreme limitations in terms of what they can do. So you have organizations like UNESCO that are trying to preserve samples of ice, but there's no, their mandate is a melancholic one, if you will. It's recognizing the diminishment of ice globally and trying to save samples so that they could be studied at some point in the future. It's not something that is organized around any kind of intervention. Then, as I said, I already mentioned in the presentation, the major climate organizations like the IPCC, and then of course we have COP, et cetera, et cetera. So all of these organizations have very different sort of mandates. They're all like policy-driven sort of forums. And then I've lost my train of thought. I apologize for that. But you were asking about the relationship between organizations and local communities. Was that it? Yes, that well. I mean, this is exactly what's in some way becomes a huge issue, because the kinds of determinations that are made in many of these forums are operating and are thinking at a scale that is a global scale and can't take into account very specific local and regional kind of specificities. And so in context, say, for example, that where we were working in Ladakh, there isn't, you know, people need to survive, and they're adapting as best they can, and there's no like sort of, like for example, in the village of Ashgal, there's no regional water management system. The water in that community has always come from the glacial stream paths, and they have a very long history of sharing water resources equally that's completely organized from the ground up by the kind of community. They're not part of a kind of national sort of water management sort of system. So you have like local communities. I'm saying the thing that we all know, that are just doing their utmost, their best to try and cope with these kind of like changes that are coming along. And then you have larger organizations who are, maybe they're operating at the local scale, but I would say the same with our project. It was more of like a pilot project in trying to use acoustics as another method for measuring and monitoring glacial dynamics. But you know, it wasn't a project that had a long-term, wasn't sustainable financially. The funding wasn't there. The funding is there to go back and to measure those stakes in the ablation zone at Drangdurn Glacier, et cetera. But the funding wasn't there to ensure that we could continue to work with acoustics and do the kind of training that would be required to carry the project on. So I think that kind of relationship is always one that's incredibly complex and subject to so many kind of like variables that are really hard to kind of manage. And then but even in a place like Leh, there's so many NGOs working already there with varying sort of environmental impact sort of agendas. So you have like also sort of in some way a competing NGO culture, for example, that's also operating, and there's not always the best of, of also just basic knowledge sharing would be quite helpful. But in a place like, if we think about the Himalayas, there's the kind of like the geopolitics are so, there's no sharing between the scientists who are doing sort of monitoring the Tibetan plateau. There's no sharing between Pakistan and India. Maybe the only sort of knowledge transfer that's happening might be between sort of Nepalese scientists and those working in Ladakh, for example.
Thank you very much for your lecture. I wanted to ask, you began the talk with discussing how the ice cores were nearly lost due to a political decision. How do you, to what degree do you find that changing attitudes towards the value of research and academics has affected your research methodologies and the reception of your research, especially in recent years?
I mean, I guess, well, one thing, I think every scientist I've ever worked with understands that their work has to have social impact. They understand that it has to be written into every sort of funding application, grant, like you have, like what is the sort of public-facing dimensions of the work you do, and what is it of what's its relevance to society at large? That is, in some way, you could say it's a mandate of research culture. So artists, filmmakers, architects, in some way, can play. We've sort of like we're playing maybe the role of mediators. I see myself as a bit of a narrator, or someone who's trying to tell stories and sort of mediating different sort of realms of expertise that often have their own internal logics, languages, and abstractions. So I worked with lawyers for a long time and really did a lot of work for many years in the ICTY, which is the International Criminal Tribunal for the former Yugoslavia. And so all the work, this was very, at that point, it was not dissimilar, because I was grappling with the, in some way, what seems like the kind of abstractions of the legal imagination, and the ways in which those kinds of legal decisions then work themselves out on the ground. But I really saw my role and the kind of, as in some way someone trying to mediate, not just, I mean, I know that people have worked with me because, oh, we need to communicate our results, and you can do that for us. And it's somewhat, I don't have a problem with like playing that role if it's a useful role. I take that on, but I still try and move it beyond just the kind of like instrumental, like communicating like the research findings of scientists. I think what I've been able to do, or at least is oftentimes, I think, is sometimes as a filmmaker, it's seeing your own. It would be like seeing your own space of labor and work through someone else's eyes. And I think when I've shared materials that I've shot, that's one of the responses that often comes in my way. People are sort of seeing, wow, this is just my workplace, this lab or this ice core archive, seeing it kind of transformed and sort of having a different sort of sensibility is often quite a, it's often quite a transformative kind of encounter. So for example, just to, maybe a short example, I've produced a 35 millimeter, a vertical film that was shot in the Netherlands at this atmospheric research center, which is, there's a 300-meter tower where they monitor atmospheric changes in pollution, et cetera. And I had been commissioned by Sonic X to shoot a 35 millimeter vertical cinema. I thought, well, this research facility in the Netherlands is ideal because the main, the main spatial object was this amazing tower. But what was really interesting in my encounters with the scientists was we started talking. It was just like, this is the kind of thing that happens if you start to spend time with people, and they're going, well, it's really interesting. They're saying, we've been looking at Dutch landscape painting. I said, oh, wow, well, really? Going, yeah, we thought well, the Netherlands has this incredible history from the 17th century of Dutch landscape paintings, and in particular, a lot of these paintings, like Jacob van Ruysdael, they painted the skies, and they painted cloud formations, and there's hundreds of these paintings, and they said, we're starting to look at those because it might be useful data for us to understand atmospheric conditions before instruments of measure were invented. So having this conversation with them, I just use this as an example because I was coming from a arts and humanities background, and they were just as an anecdote telling me about these Dutch landscape paintings that they're looking at and going this is amazing. This is art history has a kind of incredibly valuable role to play in this sort of context and is being kind of revisited again for very different kind of reasons. And then the data, which would be called proxy data, then has to be aggregated or correlated, shall we say, with other kinds of information. Could be farmers' almanacs, things like that. But So it's just to say that I think that when you're engaged with interdisciplinary work, you have to spend, if you spend enough time, you also start to find these kind of points of sometimes intersection or commonality where you realize both of your areas of practice and work actually have the capacity in some way to be transformed by the other. But that only happens, I think, if you actually spend enough time with people, and also, of course, it's also sometimes just kind of pure happenstance or sort of luck. But I've been able to work with a fair number of climate scientists who had this sort of who were prompted into thinking, into sort of engaging with sort of cultural materials in relationship to their research, and saw the value in that. And certainly that would be the case with using acoustics, which is considered a more pioneering mode of analysis in glaciology, very much so. It's a bit of an outlier. Remote sensing is now pretty much central to the study of ice sheets and glacial retreat, but not acoustics isn't. And yet, who are the people, who are the practitioners who work with acoustics? Well, they're musicians, there are bioacousticians, etc. It's another place where one can sort of meet. Yeah.
Thanks. I found it really interesting how you had your use of language in making truth, where that might be contrasted with scientific facts, and that's what you go between in your lecture with data, technology, and then going through a process of making truth as well, and then having that also amplified with the scientific truths, and then oral history truths as well. And I also found that I even just realized at the end your use of ice in that is a nice poetic illustration of that dichotomy or play where you have something fixed, this fixed ice core, but it can melt, so you have to keep it or make that truth. Mm-hmm. So I guess my question on that is, I think it's easy for people to maybe fix on one side more than the other, become sort of polarized. Like hard scientists only focus on facts or only focusing on the story or the oral history. I was wondering if you had any stories on when someone that was focused on one aspect of that truth might have been brought into that dance that you have, and maybe brought to the other side or brought more into a full understanding.
I mean, I would probably say, thank you for that question, and I would say in some way it's a bit of a false opposition, because as I was saying, I think what we have is you have the sort of the formats in the sciences scientific findings are sort of driven by the necessity for peer-reviewed publication. So you have a very particular kind of form in which scientific findings need to be communicated and disseminated. And now those kinds of formats, there's no really space for any sort of ethnographic account of lived experience or personal experience. But of course, that's always the case, and that's always happening. And all of the people that I've worked with have very very sort of rich understandings of their day-to-day interactions with the materials that are then going to be in some way, through their research findings and through the analysis and through the presentation at, say, climate forums or through publication and peer review, et cetera, going to then sort of eventually produce some account of some sort of truths that perhaps maybe acted upon, or maybe, as I said, maybe the basis for sort of policy decisions, etc. So I think there's a tendency sometimes to position the sciences as the fields of objective reality, and a scientist is somehow immune from the more kind of like the messiness of lived experience. This is subjective relationships that we have, but most glaciologists that I know they grew up really enjoying spending time outside. This is what brings them into their work. They were born born a glaciologist or anything. So I think, but then the other side to your question, in forensic architecture, we were focused very particularly on the architecture and the production of truth. Everything that we're doing was looking at the way in which truth-making practices are also a design kind of practice. And what counts as evidence, who's considered a kind of expert, who has the legitimacy to proclaim a truth or to name a truth. We really had investigated all of the ways in which that is the consequence of a very elaborated set of practices and partisan decisions, etc. So it's not to say that there's no truth, but we have to understand that all of those. So yeah, ground truthing is a practice, as A.L. says, that it's not a fact in and of itself, but the point is that these ground truthing practices need to be polyperspectival. Excuse me, I need some water. So by that, what A.L. is really meaning is that all of these different accounts of events are operating in some way in tension with each other, and there's a kind of redistribution of the narrative field. And there might be moments where you want, I'm reminded of this early article by Bruno Latour, who spent a whole lifetime arguing for the social construction of facts, and he confronts this moment in his life where he goes, actually, I do want to say some things just are fact, and we don't need to insist that they've been constructed, like socially. And he was referring specifically to climate change at the time, and that thousands of the world's sort of top scientists were in agreement. So can we really talk about climate change as a socially constructed sort of fact? But I don't know, maybe that goes to answering your question a little bit.
Thank you for your presentation. I've been interested in forensic architecture for a long time, so I appreciate learning more about it. I'm just curious in kind of your journey to your career, if forensic architecture came first or your interest in climate change came first, and how you kind of brought the two together, because you've mentioned how the truth-telling and the design kind of go hand in hand. So how did you reach the collaboration between the two of them?
Excuse me. Forensic architecture, when we started, it was A.L. and myself in like 2011, and of course today it's a much bigger agency with 30 plus staff. My background is media and sort of like both analysis and studying. I mean, in some way, A.L.'s background was architecture. And so I was sort of the media person, he was the sort of architecture person. But if you look at forensic architecture today, you'd say it's all kind of media. And in some way, so the two of us, in some way, at certain point, so, like when you're assembling thousands, sometimes thousands, but hundreds of images that have been uploaded to reconstruct an environment, so to create what in forensic architecture we call an image complex, and we'll say there's no such thing as an image anymore, it's only ever images, and every image, unless it's a computationally produced image, and an image, comes out of some sort of reality somewhere, and the task is to situate that, which is much easier to do when you have, say, GPS-enabled sort of smartphones, obviously, but in the early days of forensic architecture, our work with media and images was somewhat different. So I think it was my practice as a media person is how my role in forensic architecture emerged. And I was working mostly in the early days, and also the material witness book is much more an engagement with legal media. A lot of the chapters deal with very specific cases that I'm following that enter into legal forums. So for those of you who know the work of forensic architecture, the forum, the forum is an important dimension of the practice, because the forum is like, it's the making public of the investigations, either into existing forums, so they could be legal tribunals or people's tribunals or even like cultural assemblies, but it's also the production of a forum that doesn't sort of exist. So all of the work that in the agency that I was doing was, it had more of a focus on like human rights violations coming out of situations of like, in particular, like war and ethnic conflict. But the agency is also involved in all kinds of environmental, like investigating environmental crimes. So in some way, we kind of both developed, I think, along kind of parallel tracks, because in some way, the origin of forensic architecture, where there was a kind of like a crime with a perpetrator and a victim, and an attempt to produce a kind of like to spatially reconstruct a complex set of events. Eventually, FA also encounters, okay, well, there's events in which there's not a single, like there's not a kind of clear like victim-perpetrator relationship. We're talking about things that are structural, that have emerge out of the long durées of history, of colonial history. So the case, a lot of work around environmental, like contamination in Gaza, for example. Shurda has produced a whole book on that, but also the recent case that looks at into the genocide in the historic colonial genocide of the Herero in Namibia by Germany, had to really delve into try and look at the environment and see like, okay, where do we find evidence and clues for this historic genocide in the absence of an archive, in the absence of the archive and in the absence of evidence. So land had to play a really important and crucial role in sort of harboring sort of traces and of the, like, in very kind of like diffuse ways, in fact. And so the interest in environment and my own, I think our two trajectories sort of unfold in a similar kind of like along kind of parallel kind of tracks, where there's a realization that like you can't look at many of the crimes and the injustices and violences that forensic architecture is analyzing without understanding the broader contextual kind of histories that produce that. So to understand, say, internal dispossession in Syria because of the consequence of like ongoing kind of drought along the Euphrates River Valley, that then, yes, the investigation might be looking into like Assad's like torture prison, but at the same time has to acknowledge a whole set of kind of causal relations, and those are often also environmental. So yeah, I think that's a bit of a rambling kind of response. So, and I think today our practices are sort of somewhat sort of, kind of mutually entangled. There are moments, like the work that I did for the Toronto Biennial, for example, called Cold Cases. Okay, there I needed to work with forensic architecture in a really pedagogical way. These are like the weaponization of temperature in the production of very grievous human rights violations, and just wanted to be really clear about that. This wasn't where some of my own work is. I'm developing a different sensibility that's not about like oftentimes trying to denaturalize an image or to tell, the sensibility is not in the service of pedagogy or making a very clear set of kind of perhaps legal arguments, etc. So different projects need different strategies. So, I mean, one of the things that's, I think, really important is forensic architecture doesn't have the liberty to make editorial decisions when they're editing a video that aren't absolutely like central to the story that is being told. Whereas I give myself permission to tell a story in a particular way and bring in material and sounds that aren't necessarily part of that context. Forensic architecture doesn't have that as an option because everything has to be verifiable. Because of the degree of cross-examination and critique and pushback that gets levied against investigations for any move that might be seen as somehow unsubstantiable or, not part of a very specific kind of regime of truth, if you will.
Okay, yeah, that was really, thank you very much, so fascinating and also beautiful. I mean, and this part is where my question comes from around the, the pathos of the beauty of the ice and the sadness of what's happened. And I wanted to ask you a little bit about the photography. And there was a show that I saw in Winnipeg, but it started in Ottawa, Dark Ice. Leslie Reed and Robert Kotick, ice photos. I don't know if you overlapped with them or, anyway. So I was just interested to hear you talk about the photography and that relationship between the beauty and the destruction. Yeah.
I mean, I think for me, the relationship to photography is one of optics. I've always been interested in the crystalline structures of ice that are also optical systems, and they're refracting light in very particular ways. And so there's always been, there's a number of kind of projects where that sort of comes together. So this understanding snow as an optical system that is producing a very particular, let's say, visual, a very particular set of visual expressions as a consequence of the way that light is moving through kind of snow crystals. I think there's a very direct analogy. It's a kind of proto-cinematic, if you will, I would say. So there's that aspect. In most of I recognize that I've had to rely on, I need sound to denaturalize some of these images and to take it so that we're not just in this sort of documentary realm of the sort of nature photography. So I've really had to use sound, but also, something that isn't so maybe apparent unless, one of the things that most of the films I make actually look at labor practices and spend a lot, it's a real-time filming of people's working with certain kinds of materials. So for me, the filmmaker Chantal Ackerman is a very important influence because of her focus on sort of the minor dramas of the everyday and staying with the space of work and labor, and not just sort of cutting to another kind of sort of scene. So at least the films where people are and their workplace is and their site of their workplace or the place that they're living is very much part of the project is to stay there. So and maybe a final point I could make in the Listening to Ice, which was a project and a series of workshops, and I also documented some of that, so that's why we have clips. but also it was really important. I wanted to stay with images of people listening, we don't hear what they're hearing, we see them listening. Jigmet, you can see Jigmet moving with his hands, and you can see him sort of starting, like I know that what he's describing is the grinding sound that the ice is making and things like that, but I also really wanted those moments where we don't immediately just fill in all the gaps, so that as a viewer, we maybe don't even speak the language, we don't understand what's being said, but we're watching people engaging in something and they're listening to these subsurface emanations. And I could have just recorded that audio, and then we would also have that same experience, but there was a moment where I actually want to really stay with the image of observing someone who is doing something else that we don't have full access to. So I do think these histories of photography are really important, and I do recognize a certain form. I am in some way a formalist. I admit that, I recognize that in the projects, but I think there's definitely a relay in terms of histories of image projection and the photographic as a lens-based system. And when you're dealing with ice, you're dealing with an entire optical world composed out of, at a structural and micro level, you're dealing with crystalline formations that are the foundations of say, lens-based technology for imaging the world, yeah.
I think I'm going to cut it off there. I know I've asked some of you just to come up after and ask questions to Susan, but I just think of your concluding lines on this crystalline world. It's like the most J.G. Ballard line I've heard this evening.
Sorry.
And incredibly appropriate to everything you've shared with us.
No one's ever compared me to J.G. Ballard.
Well, that's high praise indeed. So please join me again in thanking Susan Schuppli for this wonderful evening.
Didn't realize we had run over time a little bit.